How's it going, guys? Today we're going to be going over 3.2 day one. And what we're doing today is we're going to be writing a quadratic function when we're given the vertex and one additional point on the graph. So it's very similar to what we've done before. So what we want to do is we're given the vertex, we're going to plug it into the quadratic function of f of x equals a times x minus h squared plus k. We're going to plug the point of values of x of y into the quadratic function. Remember, it's y is the same as f of x. Don't forget that. We use them kind of interchangeably. And solve for a. And to solve for a, you want to isolate it and get it by itself. Okay. So for this problem here, we have the vertex is 3, 2. Our point is 5, -6. So we're going to use these 2 points, and we're going to put them into the quadratic formula, or the quadratic function. So let's go ahead and do that. We have f of x that equals our a value, which we do not know what it is yet. Parentheses x minus h, our h is 3, all of that squared, plus our k value, which is 2. Remember, h is the x value of the vertex, and k is the y value of the vertex. So now we need to get a to be the only variable in the equation. To do so, we're going to go ahead and plug in our y and our x value for our extra points. So we get -6 equals a multiplied by 5 minus 3, all of that squared, plus 2. Let's go ahead and simplify it some more. We get -6 equals a, 5 minus 3 is 2. We get 2 squared plus 2. Let's minus 2 on both sides, and we get -8 equals a times 2 to 2 raised to the 2 is 4a. We're going to divide by 4 on both sides, and we get that -2 equals a. So once we have our a value over here, we're going to go ahead and plug it into the formula. So we get f of x equals -2 multiplied by x minus 3 squared plus 2. So this is what our quadratic formula is going to look like in vertex form. And now we're going to figure out which way does the graph open. And remember, this is determined by a value. If the a is less than 0, it opens down. A is greater than 0, it opens up. So in this case, a is less than 0, or in other words, it's negative. So it's going to look something like this. So it opens down. Okay? We have another problem over here. Let's go ahead and do it. So it's going to be the same thing. We have this formula here, f of x equals a x minus h squared plus k. Our hk value, our hk is from our vertex over here. So we have that. So let's go ahead and plug it in. We get f of x equals a x minus our h, which is -1, all that squared plus 5. So we're going to go ahead and plug in our extra point in now, 0, 8, 8 into the f of x, 0 into the x. So we get 8 equals a of 0 minus -1, all that squared plus 5. We're going to minus the 5 on both sides. So we get 3 equals a multiplied by 0 minus -1. It becomes +1. So you get 1 squared, which is just 1. So our a equals 3. So we can go ahead and plug that back into our equation. So we get f of x equals 3 multiplied by x minus our h value of -1. So minus -1 gives us +1, all of that squared, plus our k value of 5. So now let's see which way does it open. Same thing, we're going to look at the a value. In this case, a is greater than 0, or a is positive, right? And since a is positive, it's going to look something like that. It's going to open upwards, right? It's going to open up. I'm going to leave this problem for you guys. We have the completed notes online, so you can double check your work there. And just go on to a word problem. All right. My biggest tip I can give to anyone doing word problems is to always draw a picture, especially when it comes to math. You have something like this, just go ahead and draw pictures so you fully understand everything that's happening, okay? So in this problem, it's saying there's a bald eagle, it grabs a fish from a mountain lake, and it flies to an altitude of 256 feet above the lake. At that point, the fish manages to squirm free and falls back down into a river flowing out of the lake after falling 3 seconds. The fish is 112 feet above the surface of the lake it was taken from. So what is the height of the fish after falling another second? So it's asking for us, we need to know what the height of the fish is at 1 second after the third second, and so the fourth second. So let's go ahead and draw a picture, or a graph really, so you can kind of see what this graph is going to look like and what we can take from this word problem, right? So first thing to sign is that this bird, the eagle, grabs the fish and flies to a maximum of 256 feet above the lake. So we know that the maximum point on the graph is 256. So we have 0, 256 right here. And we know that 0, 256 is going to be the vertex, since the vertex will always be your maximum or your minimum point, since it is the only turning point of a parabola. So in this case, the vertex is 0, 256. And let's go ahead and finish up the graph now. We know we start at this point here, at the 0, 256, and the fish starts falling downwards until about x equals 3, or in other words, after 3 seconds, and he is about 112 feet above the surface of the ground. It's not on the scale, but let's just bear with me. So it's something like this, okay? And what we want to know is what's going to happen in the fourth second, right? So we know this point is 3,112. So our other point we know is that we're going to use is 3,112. Okay? So let's go ahead and solve it. I'm going to solve it in the bottom here. I don't have enough room up top. So to solve for the function, what we're going to do is what we did in the previous slides before, is that we're going to plug in our vertex into the vertex form of the equation. So f of x equals some a, which we're solving for, of x minus h. We said our h is going to be the vertex of 0, 256. So x minus 0 squared plus 256. So we're going to use our other point of 3,112 now to figure out what our a value is. So the y value of 112 is going to be substituted in for f of x of our a, which we're going to be solving for. Our x is 3. 3 minus 0 is just 3, so it's 3 squared plus 256. Let's go ahead and subtract 256 from each side of the equation. And we end up getting 112 minus 256 gives us a negative 144. That equals 3 squared is 9, so equals 9a. And just go ahead and divide by 9 on both sides. And we get negative 144 divided by 9 is negative 16. And 9 divided by 9 is 1, so we're left with a on the right side of the equation. So we get that our a equals negative 16. So let's go back to the top and plug in our equation. So from here we know that f of x is going to equal negative 16 multiplied by x minus our h value, which is actually 0, so we don't actually have to write the minus 0. So it's x squared plus 256. Okay? So now we're going to figure out what happens at that fourth second, the second after the third second, which is how the problem words it. So what we're going to do to figure that out is we're going to plug the 4 into the equation, because if you want to know what happens at x equals 4, we need to plug 4 into the equation. So we have f of x, that equals negative 16 multiplied by 4 squared plus 256, right? 4 squared is just 16, so we get f of x equals negative 16 multiplied by 16 plus 256. So negative 16 multiplied by 16 is actually negative 256 as well. And negative 256 plus positive 256 is 0. So we know our f of x is 0, or in other words, the height of the fish at x equals 4 is 0. So after falling another second, the fish hits the lake, or gets back into the lake, however you want to word it. but at that point it's right at the surface of the lake. Okay. So our last problem of the notes is about this archer. So during a competition, an archer flies an arrow at a target on a hill. The arrow reaches a maximum height of 8 feet 3 seconds after it was fired. So after 3 seconds after he fired it, it reaches a maximum of 8 feet. The arrow hits the target 5 seconds after the archer releases it. If the arrow is released from a height of 6 feet, how far above the ground is the target? We're going to assume the relation is quadratic. So we're going to do the same thing we did before. I'm going to go ahead and draw a graph so you can understand everything that's happening. So that's my graph. And what we know from the very beginning is that we have a maximum at 3,8, right? That's the first thing they tell us, that the vertex is 3,8. So we can fill that in right over here. And we know it's the vertex since it tells us that it hits a maximum height of 8 after 3 seconds. So if it's a maximum, it's going to be the vertex. And we know h is going to be 3 since time is always going to be the x value. The x variable is the independent variable. Time is independent. X will always be time. Time will always be the x value, sorry, because it's always independent, okay? So we know what our vertex is. Now let's try to figure out where this thing begins, okay? It tells us the archer fires an arrow, so we know the graph is going to start at the archer since he initiates this whole graph because we're following the arrow. And we're told that he fires it 6 feet above the ground. So we know at 0.6, that is where the archer shoots his arrow, where this whole thing begins. And we know it actually goes up a little more, up to about 8. Right over here, it's called at 8. So we know he goes up, the arrow kind of goes up to here before it starts to go back down, and it hits a target at at x equals 5. Okay, so looking at this graph, we know this point right here is 5 and some y. We actually don't know what that y is yet. We're going to be solving for it. So to figure this out, we're going to do the same thing. We need the function. That's the very first thing we need. So we need the vertex, we need the point, and if we're looking at the graph, we see our other point is 0, 6, right? It's the only other point of the graph that we have, so that's what we're going to use. So let's go ahead and plug both these points into the vertex form of the equation. So we have f of x, that equals our a value, if you don't know, multiplied by x minus our h, which is 3 squared plus 8, right? So let's go ahead and plug in our point as well. We have 0, 6, so we get 6 equals a multiplied by our 0 minus 3, since our x point is 0. All that squared plus 8, that's minus 8 on both sides. 6 minus 8 is -2. That equals a. 0 minus 3 is -3. All that squared, -3 squared is just 9. So we get -2 equals 9a. And we're going to divide by 9 to isolate the a. So we end up with -2/9 equals our a. Okay? So we figure out what our equation is. We got our a, so we know what the equation is. We can fill it out. So let's go ahead and plug it back in. So we get f of x equals -2/9 multiplied by x minus our h value, which is 3 squared plus 8. And that's what our function is. So now we can figure out what the height of the target actually was, right? So to know that, look at this 3 lines over here. The time the target is hit is at 5 seconds, right? We know at the 5th second, the target got hit. So what we're going to do is we're going to plug in 5 for x. And we do that because, like I said, time will always be x, will always be the independent variable, okay? So we're going to plug 5 in for x, and we're going to see what our y value is, and our y is our height. So we plug in 5 in for x, we'll know the height of the arrow at that specific point. So we have f of x equals -2/9 multiplied by x minus 3 squared plus 8. Let's divide this up a little bit, give us a little more breathing space. Okay, so let's go ahead and solve it. F of x equals negative 2 over 9. Let's plug in our x now. Our x we said is 5, so 5 minus 3 squared plus 8. 5 minus 3 is 2. So f of x equals negative 2 over 9. 5 minus 3 is 2, so we get 2 squared plus 8. 2 squared is 4. So if 2 squared is 4, 4 times negative 2 just gives us negative 8, right? 2 squared is 4. So we multiply the 4 with the 2 nines, so we get negative 8 over 9, all that plus 8. And to add these up, remember to add fractions with other numbers, the denominator has to be the same on both numbers. So in this case, we need to change the 8 into some number over 9. So I'm going to put the 8 over 1 and multiply it with 9 over 9. Since 9 over 9 is still 1, has a value of 1, and then I can add them up. So negative 8 over 9 plus 9 times 8 is 72. All over 9 times 1 is 9. And 72 divided by 9 is 8, so the value didn't change. So 72 plus 8 gives us positive 64. And we're putting all that over 9. The denominator just stays the same all the way across. So we get 64 over 9, which is, I believe, about 7.1. Okay, so we know the height of the target is 64 over 9, or about 70 or 7.1. Okay, and that's it for today, guys.